It's time for another amazing chemistry video with Mr. Stapleton. Grab this one, sit back on, enjoy a nice coffee. Hi guys, welcome to this video in the organic chemistry series, and this one's going to be all around amides. Now amides are really important in organic chemistry, and particularly when you're looking at bioorganic chemistry. So amides are something that you'll find in proteins, which are kind of like the building blocks of a lot of things inside our body. We're not going to go into too much biology in this one, but what we're going to do is just have a look at amides, how they're formed, and kind of where you find them. So the amide functional group is this one. Okay, it contains a carbonyl, which is a carbon double bond oxygen, and then a nitrogen as well. Normally it's a nitrogen with hydrogen there. Okay, so that's the amide functional group. Now that comes from two different functional groups. Okay, it comes from a carboxylic acid. Okay, so carboxylic acid, which comes in to make that part, and it comes from an amine or an amine. Okay, which comes in to make this part here. Now, what happens is when these two combine, we actually eliminate out a OH from here and a hydrogen from here, and that eliminates out as water. So they're formed via a condensation reaction between a carboxylic acid and an amine. Okay, so the actual equation for it, if you want a general equation, is amine plus carboxylic acid, I'm going to shorten it, sorry, will give you an amide plus water. Okay, so it's a condensation reaction, elimination of a small molecule. If you watch the video on polyamides, you've probably got a good understanding of how they're formed anyway. So in order to draw the amide that you get from a amine and a carboxylic acid, it's actually really straightforward. So let's say we have this one. Let's say we start with propan 1 amine, and we react that with butanoic acid. Okay, so what I always do, and I recommend that you're doing this if you're doing it in the exam, is I actually draw on a piece of paper on the side in pencil and put the two functional groups close to each other. So we've got propan amines, we've got CH3, CH2, CH2, so we've got the three carbons in there, and then the amine I actually draw with the functional group like that. So I just expand out the functional group a little bit. And then butanoic acid, I do it with the functional group coming towards the other one. So there's the OH functional group, there's the carboxylic acid functional group there, and then we need three more carbons here to make this into a butanoic acid. Now the reason it's really good to do it that way in the exam, and particularly in pencil, is because you know it's formed via a condensation reaction where you eliminate a small water molecule. You can actually eliminate out the water. So we take out one hydrogen from there, and we take out the OH from there. Now what you've got is the two next to each other, and you know that you're just going to bond them up like this. So what you can do is redraw this molecule now. Okay. And the good thing is that they're not going to ask you to name these in the exam. So when you're doing the amide, it's usually good to have the hydrogen on one side, the carbonyl, the oxygen on the other side. Okay, and you end up with your amide like that. Now, this amide functional group is very, very polar. Okay. Now, what we mean by that is that this oxygen is delta negative, this hydrogen is delta positive here, and so you can get hydrogen bonding coming off of these, all right? Because you've got hydrogen attached to electronegative nitrogen, you've got a very electronegative nitrogen here which can bond to the hydrogen on another amide, and so these have quite a high melting point and boiling point because they've got very strong hydrogen bonds holding them together. So really recommend that you practice sort of doing this. It's really easy to go backwards as well. If you've got an amide like this and you need to work out what the amine and the carboxylic acid are that was used, all you do this time is again draw it in pencil, but this time break the amide bond, so the link between the nitrogen and the carbon, and then put your water back in. You know you need to remake a carboxylic acid, so put the OH back in. Okay, to make your carboxylic acid, and there you have your initial starting products again. Now, What you need to understand is that when we're going backwards like that though, where we're going from the amide back to the carboxylic acid and the amine, that you can actually do it one of two ways. It's pretty straightforward when you're creating your amide, just to put them together, and there's only the one way you can get your amide. But when you're hydrolyzing it or putting your water back in, we can do it either under acidic conditions or under basic conditions. So if we're doing it under acidic conditions, what we're doing is we're doing it in the presence of H+. Okay? So when we're doing it under H+ conditions, normally when you're doing your hydrolysis, you would get the amine and the carboxylic acid. Okay? But what you've got to remember, and hopefully you've watched the video on amines, is that an amine is a base. Okay? So if we go back to that one we just used before where we had butanoic acid, we're going to get still butanoic acid as our product, because in acidic conditions, an acid doesn't change. Okay? However, the propan-1 amine that we have, the nitrogen with its lone pair of electrons is going to attract this hydrogen to form the protonated amine part. So what we're actually going to get under acidic conditions is a protonated amine like this. Okay? So you need to understand if you do acidic hydrolysis, you're going to end up with a protonated amine, and they quite often like to ask those questions in the exam to make sure you know what's actually happening. The other way you can do the hydrolysis is under alkaline conditions. So alkaline conditions mean you are doing it in the presence of a base, okay, and alkali is just a water-soluble base. And so in this case, what you're going to get is you're going to get your base, you're going to get your propan-1 amine, because a base isn't going to change in basic conditions. Okay, so we get just our normal amine like that. However, what's going to happen is that the carboxylic acid group is going to be deprotonated by the alkaline conditions. So in an alkaline hydrolysis, you're going to end up with a deprotonated carboxylate ion. Okay? So it's quite important that you understand the difference when you're doing hydrolysis. If you're going to break that carbon-nitrogen bond here to reform your carboxylic acid in your amine, you need to understand that if it's acidic conditions, you're going to get the protonated amine. If it's alkaline conditions, you're going to get the deprotonated carboxylic acid. As I said, they really like asking that in the exam, and so make sure you can actually do it. Now, I did say that amides are really, really common in organic chemistry. And the reason for that is because when you take amino acids, and I'll show you the general structure, there's a whole separate video on amino acids, so I'm not going to go into too much depth on those, okay? But an amino acid has a general structure which looks like this. So there's a central carbon atom with a hydrogen on it. This is a carbon chain, there's 20 different variations. But on one end, you've got a carboxylic acid, and on the other end, you've got a primary amine. So what can happen with your amino acids is these can actually react with each other to start forming long chains, okay? They make polyamides, or when we're talking about in biology, when we start adding these together, we call them polypeptides. And polypeptides are also known as proteins. So what we have here is a condensation reaction between different amino acids, and what happens is that we have an amino acid here which, actually I might put a thing on that because I think it rubs out better. So we bring another amino acid in on this side, so we have carbon, hydrogen, maybe a different R group there, carbon, double bond, oxygen, OH, like that. We've got the hydrogen there and a hydrogen there. Okay, and then we've got, again, the carboxylic acid. Whoops, no we don't, not on this end, sorry. On this end we've got the amine group. So what we've got is just two amino acids next to each other. It's a condensation reaction, and we eliminate out a water molecule. Okay, so we form a bond between the two amino acids here. What we've made is an amide group. Alright, here's our amide group in here. Okay, and because we've got now an NH2 on one end and a carboxylic acid group on another end, we can keep adding, so it's a polymerization reaction. And when we're talking about in terms of biology, we refer to this group, instead of an amide group, we call it a peptide group, which is why we call them polypeptides, many peptide groups all together. So this is really useful in organic chemistry because this allows your different amino acids to link up together. As I said, I'm not going to go into the biology, but this is what creates your triplets, which are your codes for that your DNA allows for your body to produce a whole bunch of different materials. So it's really, really useful, and it all comes down to just the fact that you've got these amino acids with an amine on one end and a carboxylic acid on the other end that can bond to form polypeptides. So that's quite often where they bring up the questions in Year 12 chemistry. There is a whole separate video on amino acids and proteins, so I suggest you have a look at that as well. But the key thing that you need to look at for the amides is firstly to be able to identify an amide functional group with the carbonyl part and the amine coming together to form an amide. It's formed via a condensation reaction where we eliminate our water. This group is very polar, able to form hydrogen bonds to other amide molecules, so we get very high melting point and boiling point compounds. What can happen is you can hydrolyze these under acidic and basic conditions. Make sure you work out the products of those. And when you have them as amino acids, where you have a carboxylic acid on one end and an amine on the other end, you can form polypeptides or proteins, which are polyamides, and we've looked at that in another video. So hopefully this has been fairly straightforward. There's a couple of videos I said that really link to this. The one on amines you might want to look at, the one on amino acids and proteins you might want to look at as well, and also the one about polyamides. As always, if you've got any questions, just ask, but I hope this has been helpful. Thanks, guys. This is real love. This is real